Hey guys, it's Mrs. Meller. Here I am. I'm going to teach you about solving inequalities with variables on both sides and compound inequalities today. So here we go. All right. So let's say we have an inequality or a variable on both sides of an inequality. Well, just like we had with an equal sign, okay, we have to get the x's on the same side. So I'm going to get the 3x over here because this x is already by himself and the 8's over here. So I'm going to subtract 3x from both sides. So negative 2x equals 8. All right, so we're going to do the same thing with the inequality here. I'm going to subtract 3x from both sides. That gives me negative 2x is less than 8. So I'm going to divide by negative 2. Now what happens when I divide by a negative? If you said the inequality symbol changes, you are correct. So we have x is greater than negative 4. So negative 4 is my important point. Make sure that when you write your line, your number line, it's correctly labeled. So we have negative 5, negative 4, negative 3. And let's see, we're not including, so we're going to use a parentheses. And we're going to go bigger, so we are going to go to the right. So parentheses and get bigger. All right, next. Here we are. This one's a little different. It's got some decimal involved in here, so I'm going to subtract this one just because it's smaller. Draw a line. So I have 2.5 x minus 1 is less than or equal to 4. Add 1 to both sides. So that gives me 2.5x is less than or equal to 5. And if I divide both sides by 2.5, 5 divided by 2.5 is 2. So x is less than or equal to 2. All right, so here is 2. That's going to be 3. Over here is going to be 1. And x is less than or equal to, so I'm going to use a square bracket. And I'm going to shade to the left. Okay? Square bracket means include the endpoint. All right, here's the last one for this slide. So I have, there it goes. All right, so I have parentheses around this, and you guys should know that means to distribute. So I have 6 minus 6x is less than 3x. Add 6x to both sides to get the x's on the same side. That gives me 6 is less than 9x. Divide, so I've got 6 is less than 9x. I'm going to write it over here. Divide by 9 on both sides. And 6/9 can be reduced. So I'm going to divide the top and bottom both by 3. So that gives me 2/3 is less than x. So here's 2/3, here's 1, and here's 1/3. So let's see, x is greater than 2/3, so here's 2/3. It's not including, so I'm going to use a parentheses and go bigger. Okay? Oh, and I need to make sure that I write all my interval notation here. I've got negative 4 to infinity. I've got negative infinity to 2, including, so just read it from left to right. Arrow means going on that side's infinity. Bracket means include the endpoint. Here, starting is parentheses at 2/3. Keep going until I get to infinity, and I always use a parentheses next to an infinity. Okay? All right, next. Oops. Oh, this one's a little tricky. This one has multiplying on one side and stuff that wasn't simplified on the other. So first, let's just deal with one side first. Let's just deal with this left side of this one. I'm going to distribute the 2 because that's what I do when I have a number being multiplied by a binomial. So I have 2k minus 6 is greater than 6 plus 3k minus 3. 6, so over here now, I'm going to simplify by getting 6 and negative 3 together. 6 minus 3 is 3. So 3 plus 3k, and over here I have 2k minus 6. Okay, now to get the k's together, I'm going to subtract 2k from both sides. So that gives me negative 6 is greater than 3 plus k. So to get the k by itself now, this is what I have. I'm going to subtract 3 from both sides. So negative 9 is greater than k. Great, so now I have my important point, and I have to make sure that I'm going the right way. So this is going down because negatives go down in number as they get bigger. That's negative 10. So k is less than negative 9, but not including, so I'm going to use a parentheses at negative 9, and I'm going to arrow up. So my interval is, if I read from left to right, starts at negative infinity to negative 9, not including. Okay, and this last one has lots of decimals, so I'm not going to let that scare me. I'm going to keep moving on. Subtract 0.04y from both sides. So I have 0.5y is greater than or equal to negative 0.5. Well, I'm going to divide both sides by 0.5 to get y by itself. So y is greater than or equal to, because I didn't divide by a negative, I don't have to flip it. Negative 0.5 divided by 0.5 is negative 1. So there's negative 1, 0, negative 2. So y is bigger, so I'm going to shade to the right and include it. So I'm going to include negative 1 and shade to the right. So we have bracket negative 1 to infinity. Ta-da! Okay, so that's how you deal with a variable on both sides. Sometimes inequalities are true no matter what the variable is. Like, let's say I said 2 is less than 3. That's true all the time, right? Because 2 is less than 3. And sometimes inequalities are false no matter what the variable is. Like if I said 1 is greater than 7. That's false. This is wrong, okay? That's an R, not an H. Wrong, okay? That's wrong, and this is a right statement. So if it's a true statement, then your inequality will have infinite solutions, okay? So the solutions for true are all real numbers, okay? And if you have a false statement, like 1 is greater than 7, you're going to have a solution that's no solution, okay? So there we go. Let's see what we've got here for an example. All right, so here I have 2x minus 7 is less than or equal to 5 plus 2x. Well, I have to get the x's on the same side, so I'm going to subtract 2x from both sides. But when I do that, look what happens. It says negative 7 is less than or equal to 5. Now the question is this a true statement? Is negative 7 smaller than 5? Yes, because this is negative and this is positive. So this is a true statement. So the solution is all real numbers. Okay, and for my solution, I would just graph the whole thing. Okay, and my interval would be negative infinity to infinity. Okay. Now what happens here? Well, I'm going to have to distribute the 2, so I have 6y minus 4. Minus 4 is greater than or equal to, distribute the 3, 6y plus 21. So I'm going to subtract 6y from both sides. I've got negative 8 is greater than or equal to 21. Well, is negative 8 greater than 21? Oh no, definitely not. So that means this is false, so I have no solution. Okay, which looks like that. Okay? All right, so there we go.